So we're going to move on to chapter 6 now. And it's going to be very, very different from what we've been doing. We're going to get back into doing some more of the Algebra 2 material. So today we're going to do 6.1. What is a quadratic and how can it be used in non-graphing situations? And we'll get to the graphing part later down the road. And maybe you've heard this word quadratic. This will be used quite a lot throughout this chapter. It's pretty much all on quadratics. So we have a couple different things to define. We have a quadratic expression, we have a quadratic equation, and a quadratic function. So here's what a quadratic expression looks like. It starts out with ax squared plus bx plus c. A quadratic has an x squared in it, and then it can have a number with x, and it can also have just a number by itself. A, b, and c, they're just numbers. So for an example, I could say it's 5x squared plus 2x minus 4. This would be a quadratic expression. You also don't have to have the x or the 4 here. You don't have to have this. You could just say it's 3x squared. This would also be a quadratic expression. As long as you have the x squared term, you're good. Now to make this an equation, you just have to add an equal sign. That's it. So I'll do ax squared plus bx plus c equals, and usually when we solve these equations, we're going to get it to equal 0, but we could equal whatever we want over that side. But once you add the equal signs, it becomes an equation. So again, I'll just make up another one. We'll just say x squared, so there's no number in front except for 1, plus 5x plus 10 equals 0. And now that has become an equation, quadratic equation. And the last one to be a function, really that just means like when we put it into our calculator, we use like the y equals. So we're just going to add on the y equals. So instead of having equal to be a number on one side, we're going to have it equal to y. So same exact thing again, ax squared plus bx plus c. It's just now equal to y. So I'll make up a pretty simple one. You can also have this combination. You could have y equals, say, 6x squared. It's possible to not have the x part in the middle, so we could just have just the outside part here, the plus c, plus 7. Again, the key part here, and I'll highlight it, is to have an x squared. We need to have an x squared. That's basically what makes this a quadratic. What we just wrote it as here in all three of these instances, it's called the standard form of a quadratic. So if you have all the pieces, x squared and x, and then the c, in this order here, it's called the standard form. So we have ax squared plus bx plus c. So that would be an example like the very first one we did, the expression, or we can make another one. Let's say 10x squared minus x plus 2. And there's only one big thing that you need out of all of these expressions, equations, and functions. A, the number out in front of the x squareds, it cannot be equal to 0. Think about what would happen if it were to be 0. If you threw a 0 in front of the x squared, you would no longer have an x squared. Therefore, it's not a quadratic equation or function or expression. So when we do these, and we might see them in different ways, where you see the x might be first rather than the x squared, or the number might come first on the end, you have to write these in order from highest exponent to the lowest exponent, which is what I've been doing. So if you look at these, it goes x squared comes first, then x would be to the first power, and then there's no x. Technically, this is x to the 0 power, but I'm not going to get into that. So it has to be written from highest to lowest. So we'll do an example. This is a quadratic. You see my mouse. Write 3x minus, and the quantity 5 minus 2x squared in standard form. So we want it to look like this here, ax squared plus bx plus c. So it has to be from highest to lowest. We want the x squared to come first, then the x, and so on. But first, if you remember, if you have something in parentheses, you have to do something called distributive property. We have a negative sign out here. It's pretending like it's like a -1. That has to be multiplied by both things. This is also something we cover in the warm-up, doing the distributive property a couple times. So this becomes 3x, -1 times 5 is -5. -1 times a -2 becomes a positive 2x squared. So now we don't have the parentheses anymore, but we have to rewrite it in standard form. So let's do that. I will put the 2x squared first, and then we have to do the 3x next, so it'll be plus 3x because it's positive, and then -5. Now it's in standard form. Not too bad. Now we're going to work on something a little bit newer, where we don't have just this distributive property once. It's going to look a little different. I'm not sure if you've seen it before or not, so we'll try one. Also, it's going to be a little new, plus also an word problem. So example 2. Chris and Sam are remodeling their kitchen. They purchase a 6-foot by 2-foot pantry door. So here's a door in red. So it's 6 feet by 2 feet. Okay. And here they're actually representing this in inches. So it's 24 inches wide here. And then the height is 72. Because that must be 6 feet, right? 6 times 12 is 72. And they're looking at different widths of molding to trim the door frame. So this is the brown part going out around the door. It's going to trim the door frame. If you've noticed that in your house, you usually have some kind of trim, or they call it molding, going around the door. If the trim is W inches wide, so it's actually labeled on here for you, the thickness of this trim from one end to the next, from here to here, is W inches. It could be 1 inch, it could be 2 inch. You can get all kinds of sizes of trim. We're going to write the total area of the door and the trim in standard form. So we're going to find the entire area of this whole thing, right? We want to find all this area, including the trim. So how do we do that? Well, first you need to figure out what in the world do we use for area. You have to remember that there's a formula for area specifically of this shape. The shape of the door and the trim combined looks like a rectangle. So you have to know, what is the area of a rectangle? How do you calculate that? So specifically, area of a rectangle is A equals its length times its width. The length times its width. So then we're going to look and see on the door in the frame here, what is the length and what is the width? And I'm going to replace that with L and W. Okay, so let's do A equals, the length of it is how tall it is. So we're going to look at this entire amount here. Let me move this here. From the very top all the way to the floor, right? This would be its length. How tall is it completely? Well, we know that from the floor, if we look at the floor of the door and the trim match up here. And then you measure up all the way to the top of the door here is 72 inches. But we're going to add on the little trim amount here, W. So this entire length here is not only 72 inches, but we also would have to add on this little thickness W here. So I'm going to say the entire length would be 72 plus W. That's going to be my length. And so I'm going to put this in a set of parentheses here. I'm going to change this L to 72 plus W. And then we're going to go over and we're going to actually look at the width. The entire length of the width here. So I go from up here all the way down to here. We're including the door, which is 24 inches, the red part from here to here. But now we're also going to add on the trim, the molding. But this time it goes on both sides and not just the one side like it did on the length. So we have an amount W here. We also have an amount W here. So the total width goes W plus, we have to add 24 to it, plus another W. So you could say this is W plus the 24 inches plus another W. That would give you the total width. And you could also simplify that a little bit. W plus another W is the same thing as 2W. So maybe we could just replace that and say, instead of doing it that way, we could say it's 2W. 24 plus, there's 2 widths of the molding. And so this will be our width here that goes here. So I'm going to put that over here. Again, in parentheses, 24 plus 2W. So if we wanted to find the area, we could just multiply these two things together. However, I don't know if you guys remember or know how to multiply these two things together if you have two sets like this in parentheses. You're used to doing one with something on the outside and doing distributive property, and doing it this way is kind of the same thing. Really what you do when you multiply these together is you do basically I call it double distribution, where you take the number, you're looking at one of these sets, you take the number here, 72, and that has to be multiplied by everything in this set. So I usually just draw the arrows and arcs here. So I do 72 times 24, and then you do 72 times 2W. Let's maybe erase that too. Like that. So 72 has to go to both of these numbers. It's kind of like the distributive property. And so we'll multiply that out. 72 times 24 is 1728. And then we have 72 times 2W, which would be 144W. That takes care of the first part with the 72. And then you have to do it again with the other piece. Now this has to be distributed to both. So I put these arcs underneath. So the W has to go to 24, and the W has to go to 2W. So we'll add on 24 times W, which is 24W. And the last piece, we briefly mentioned this before at one point. If you have W times a W, that becomes a W squared. So this is 2W squared. There we go. And then I'm going to look at all these four terms and see if anything actually can be combined. Any like terms in here? Well, this is just a number. Can't do anything with that. We have two W's here. We can add them together. And then this is a W squared. That cannot be added to anything unless we add another W squared. So we'll add the two middle ones together. That would be 168W. So we are pretty much done. The last thing we would have to do is write it in standard form, because that's what the question says. So we write the total area of the door and the trim in standard form. So we need to make sure that the W squared comes first, and then the W, and then the number by itself. So I'm going to switch these two on the outside. So our final answer would be 2W squared plus 168W plus 1728. There you go. I'm not sure if you've done this stuff before or not, and hopefully it's not too much of a shock on how to multiply these together. But again, it's kind of like double distribution. You have to do it twice. So again, this number here went to both terms in here. And then the variable here, W, also went to both things. So you end up with 4 different terms. All right. Now, for binomial, another vocab word. Really what we just worked with was something called a binomial. That is, if you think of the word bi like a bicycle, it means there's 2 of them. It's an expression with 2 terms. Fix this. 2 terms. So anything you can think of with 2 terms, for instance, the ones that we just had. The ones up here, we had 72 plus W. This is a binomial, 72 plus W. There's 2 terms, 1, 2. You could say let's say y squared minus 10, two terms. As long as you had two different things, we could say 2xy plus 10z to the third power. Again, terms are usually separated by a plus or a minus sign. So all these are called binomials. So what we just did is we multiplied two binomials together, because each of these in parentheses are binomials. All right, example 3. The expression 2w squared plus 168w plus 1728, that looks very similar and familiar. We just worked with that. It's in standard form. What are the values of a, b, and c? Well, if you remember that it goes ax squared plus bx plus c, then you should be able to figure this out. It's already matched up perfectly. Since it's in standard form, a goes with the x squared, in this case the w squared. So we'll just say a is 2. B always goes with the variable that does not have a power. B is 168. And lastly, C is the number by itself, the 1728. And that's all it's asking you to do, is identify A, B, and C. Since it's already in standard form, you could just take out the numbers A, B, and C that are out in front. Our example 4. Write the area of the square with side lengths x plus y in standard form. Okay, so this is a square. So if you think of a square, it's the same dimensions on both sides. We have x, we have a certain amount that's an x distance here, and we have a y. So the entire length, if I write this out, is x plus y, just like we did with the door. And since it is a square, that means all the sides have the same length here. So this is also x plus y, right? So what we're going to do is we're going to figure out, well, if we were to multiply these two things together, because the square area has a area of length times itself, length times length. You could say length times width, but they're the same thing. So we're going to do the area of each piece that's in here. So you can label all the sides here. All right, this would also be x and y. This would also be x and y. So we're going to actually, we're going to figure out the area of each small square / rectangle in here, and then we'll put them together to get the area of the big thing. So if you look inside here, this is a length of x. This is also a length of x. If I were to multiply them together, you would get x squared. If we come down here, we have a length of x here, and we have a length of y here. This would be x times y. Let's go up to the top right here. This side is x, and this side is y. So we could get another x times y. And then lastly, we have a y here and a y here. So this would be y times y, or y squared. So if I wanted to find the area of all of this put together, x plus y times another x plus y, we would say that this is x squared. Just add them all together. We have this block here, right? This block plus this block plus this block. All four of these combined would give you the area of the entire square. So plus, we have an xy plus another xy plus y squared. And we actually can combine things in here. We have two xy's. They are like terms. So one xy plus another does give us 2xy. So this is our final answer. We have x squared plus 2xy plus y squared. That would be the area of the entire square with these lengths. So this is actually part of a theorem, the next part here, the binomial square theorem. For all real numbers x and y, if you have x plus y squared, that means you have two of them. So this is what that means. And x plus y times another x plus y. Whoops. Which is exactly what we just did in the last problem. We have an x plus y times another x plus y. The answer happens to be what we just got here. And that will always be the case. You can just square the x's, so x squared. If I can put a 2 up here. Plus, you do x times y, and there's 2 of them, so it's 2xy. Plus square the y's. And you can also do this with x minus y squared. So similar answer, just slightly different. If you have x minus y and another x minus y, it's very, very similar. You still get x squared, and you still get 2xy. The only difference is when you add these together, you get a minus sign between them. And you still get the y squared, which you can go through this. Let me actually change that to a different color. The only difference is this minus sign. But you can go through and you can do the arcs like we did before, multiplying this to each thing and multiplying this to each thing, and you would get the same answer. So we can try one. Expand the following. We have 2r minus 5s squared. So you can use the shortcut that's up here. But if you don't want to practice doing that, that's fine. We can just practice doing the arcs if you're kind of struggling with that. So we have 2r minus 5s. Right? The squared here means that there's 2 of them. 2r minus 5s. If this thing would actually work, that'd be great. So how do we multiply these together? You're going to do the first one, 2r, and it has to go to both things in the second one here. So the 2r goes to both things. We have 2r times 2r, which is 4r squared. And then we have 2r times a negative 5s. That's minus 10rs. And then we do it again with this negative 5s. We go to the 2r. Negative 5 times 2 is negative 10. We have s and r. So I'll just write it as rs again. And then we have negative 5s times negative 5s. That's going to be a positive 25. S times s is s squared. So you look in the middle, these two things match. They're both the same. We put them together. Negative 10 minus 10 is negative 20 rs plus 25s squared. And then we bring down the 4r squared. And that's your answer. Okay, we got one more to go through. Example 6. A group of students are working on a group project, and they are given a 40-inch by 30-inch poster board. They are told to put a border on the poster board, assuming that the border is x inches all the way around. Write an equation of the area of the poster board in standard form. Okay, so they're buying a poster board. Let's draw a poster board. It's not going to be that straight. It's going to be rectangular in shape. Oh boy. Okay. It's 40 by 30. So I'm going to label this as a length here. So we have 40 by 30. Okay. And they are going to put a border that is x inches all the way around. So it looks like if they buy this poster board, they're going to put the border on the inside of it, right? So imagine cutting out these little strands to put around the edge of it. So on the inside here, we have a border. Think of it as kind of like maybe a picture frame kind of. And we know that the inside is x inches. So I'm just going to put x over here. So from one side to the other side here is x inches. We're going to find an equation for the area of the poster board. So let's think about area of the poster board is going to be, again, length times width because we have a rectangle. So what is the length? Let's see. How long is it? Oh, wait, what are we trying to find? Assume that the border is x inches all around, write an equation of the area of the poster board. So I think we're going to try to find the inside part here. So we want to find the area of this, where you're actually going to draw. So all this stuff. So that makes things a little bit more difficult because we have to really take out the thickness of this board that goes around. So it's a little bit harder to figure this one out. The length here, the entire thing is 40, right? It's 40. But we want to take out the little border here. And so we have a thickness here of x here. We also have a thickness here of x. So we're going to take that out. So we're going to do 40 minus an x and an x, which is the same thing as minus 2x. And then we're going to do the same thing with the width. If we go from top to bottom here, the whole thing is 30, but we're going to take out the thickness of x here and of x down here. So this is also 30 minus 2x. So that's your length and your width. We have 40 minus 2x times 30 minus 2x. And we're going to go through and multiply these together. So again, it's kind of like the distributive property. We do it twice to each number. 40 goes to 30. 40 goes to negative 2x. So this will be 1200 minus 80x. And might as well change the color again. We'll do negative 2x to 30. That is negative 60x. And negative 2x to negative 2x. That's positive 4x squared. Again, the only thing we can do is combine these middle terms here, which happens pretty often. We will get negative 140x plus 4x squared minus the 1200. And lastly, we just have to reorder this and make it into standard form because it does say put it in standard form. So we're going to rewrite this with x squared first. It will be 4x squared minus 140x, and then the 1200 is positive, so plus 1200. And that would be the total area of the inside where you're going to actually put stuff on your poster board. Because remember, this part out here is just a border. And so that is all for the section. I know it's kind of a long one, but now you can finish doing the huddle and the warm-up and everything that goes with it. The only thing you cannot do right now is example 7, but we can talk about that later and go over it later. So that should be it. Example 7, and then the last problem on the mastery is also a third power. We'll talk about that one later. Otherwise, you can finish everything else.